Sir, please. Sir, please sit, sir. Then sir, what? Sir.
ಇಲ್ಲಿ ಕಮ್ಮ ಸೈನ್ ಮಾಡಿಸ್ಬೇಕು ನನಗೆ ಸೈನ್ ಮಾಡಿಸ್ಕೊಂಡು ನಾನು ಕೆಳಗಡೆ ಕಾಫಿ ಬೇಕಾ Don't
Sir, biscuit, none of our only
So welcome back. Just slowly we will go to the SAGAR because our definition here practice. So let the equation y minus b0 plus b1 plus bn, then xi obviously that summation part is there, right? Now what I need to say, so we are repeating this one is equal to 0. This is not entire. This is basically called our RSS value, residual value. I'm calculating the residual value. Now as I told that from this point I will divide the two part, one will go to AI, one will go to the ML, right? Now I first complete the AI part, then go to the part, right? It comes in, right? So in AI what will happen? If you want to minimize the equation, like in power system, we have to minimize the equation. So we have to equate the square then derivative. I hope you have done this. Same concept. I am not going in detail. So if I solve, because in this entire case, this is already known to you, right? And for your analysis, already you have done something like this, and you have the straight line equation. So this straight line equation it corresponds to my y value. That means in this entire equation, this is your known quantity, this is my known quantity. The main game changer in one parameter, that is this. Or if you have the constant this is the main increment value, then this is the game changer, which will control the right? So if you do any minimization problem, our main objective is to find out the bias value. What is the bias value in the equation? Because already data you have, already the straight line equation you have, the only concept is I have to calculate the bias value. So if I take a differentiation and if I equate it to 0, the derivative, then you will be getting a bias as x into x inverse, x transpose, x inverse, x into y. I hope this equation you have seen many times in power. Same thing we are doing there. Even this one, my objective is only to difference. So you are going for A model or ML model. Objective is calculation, and I have become the final cycle. This is given calculation. We are doing some proof, but objective function calculator. Okay, so that beta corresponds to this mathematical equation. That is what I am doing. Nothing else, right? Then I show the comment. And in the first term, we have called hypothesis. Hypothesis, right? What exactly is hypothesis? It is you are assuming some type of solution, and we are doing reverse engineering. Okay, you are assuming that of some kind of solution one is there. I don't know what is. I am assuming that solution is right. So I hope in your PhD you have done a course work where you might have heard of that for null hypothesis. Okay, my question is what do you want to do? This is the same document.
P value based on P value, the P value is less than 5%. We will say that whether it will be rejected or accepted.
So actually, according to our concept of theory, null hypothesis has to be rejected. Then only you can say, okay, my main hypothesis holds good for my PhD to get defended. That is what null hypothesis is, the hypothesis which has already been described by some other researcher. You are taking that one as your reference parameter, and you are proposing another hypothesis. Okay, and you are linking your new hypothesis with the proposed hypothesis, showing that the null hypothesis is rejected because of my new concept, where I am getting efficiency plus 2% extra. This is what the
below 5%.
yes, that is the
based on.
but this is not null hypothesis, right? Now what I will do here. Now let us say you have three different variables. One is let us say real power, one is let us say my reactive power, and here I am taking some price for unit. Okay? It's a 3 dimension. In 3 dimension, let us say the dots are like that, parameters are scattered. Right? Now I am proposing, this is my hypothesis. Just understood the point. Sketch. This is my plane I am assuming. This hypothesis of the law. Now all the points are scattered inside the entire 3D surface. It is not necessary that all these points should have some connection with my hypothesis. Because I assume that this student will score 99% in the end semester exam. But maybe he knows that he will be scoring 66%. Understood the concept? This is my hypothesis of the teacher perception of the student, that the student will score 99%. But student actually knows that I am only 66%. Clear? But my hypothesis is this one, here is the student. Right? Now here the game that will come, that is called activation function. Activation function, right? I hope you heard the term called sigmoid. Sigmoid activation function, right? As in today, in our entire ML algorithm, 9 types of activation functions are there. Running activation functions. There are 13 are there, but running activation functions only, right? Out of this 9 activation functions, the game changer is called sigmoid. Okay, sigmoid, right? Why sigmoid is game changer? I also come to that point. Sigmoid formula is 1 by 1 plus e to the power minus x. Clear? That's it, right? Now, if I want to plot the characteristics curve for this function, characteristics curve means it will start from minus infinity, minus infinite to go to infinite for any value, given a little bit, right? Now, if I put x equal minus infinity, what is the entire value? It is e to the power minus, so it will be 1 by e to the power x. So then, how much will it be? See, this 1 by 1 was 1 by e to the power x. So if x equal to 100, this entire term becomes 0. 1 by 0 becomes infinite, right? Then, no, see, if I put here as an infinite, right? I am putting minus infinite. This is minus infinite, right? If I put here infinite, then how much will be getting? This is not infinite. Something to infinite is a 0. This is 0. 0 becomes infinite. So, sorry, 1 by 0 becomes infinite. Yes. What is the total term now? 0. Okay. Nothing that your middle term is here 0. So you can put here x equal to 0. How much are you getting? Not 1. This is 1. 1 plus 1, 2. Then you are getting here. Now you put here infinite. Now if I put infinite, this becomes like this. So if I put infinite, something to infinite equal to something to infinite. 0. Infinite. 1 by infinite. 1 by 1. So 1, see if it is 1 then definitely it will be minus 1, right? So you see your curve, right? Now what is saying that this is the only equation in the history of the mathematics. If you take the derivative of this equation will repeat itself twice in the final equation. I'm repeating once again. This is the only mathematical equation proposed by Ramanujan only which will repeat itself in its derivative twice. No other equation in the universe. Right? That means if I take the derivative of this one, suppose I am assuming this entire as u, then in the derivative I will be getting u going to 1 minus u. If you take the percentage, you take the derivative, you will be getting the exact same equation. Right? This is the only equation which will repeat itself twice. Right? Why it is important the logic now? That means it is saying that if you are using this equation anywhere, suppose I am multiplying some parameter with this equation, then definitely the new parameter will not change its property because it is repeating itself twice. If any parameter is repeating only one time, right, then it may change the main parameter. Suppose let us say I am the activation function called sigmoid. I multiply myself with some, right? then the final output, whatever things will come, definitely I am only null. The final output significance is the main input. I am just a carrier because I am repeating myself twice in the derivative. Whenever I take a partial derivative of any equation, I am repeating myself. So I have null value. I am just helping someone to get transferred to another domain. So that is what here I am doing. If I use the sigmoid activation function, then it will create a bridge between this dot and this plot. Here, that means what is the activation function? Activation function is a function which will help the observed point to get mapped onto your hypothesis. That is called the activation function. And the most favorite activation function is only the sigmoid activation function, as in type. Any doubt here? Anyone point out? Any questions there? You wait to answer, and then move on. Because I go for the matter. Now I'll show you something. Like I hope you know how to find equation from the data set. Suppose one data set or a two-term data is given to you. Can you find out the equation for that data? Okay, I'll explain. Just let us say you have 2 points x1, y1 coordinate, another point is x2, y2 coordinate. So what is the line passing through these 2 points? What is the mathematical equation? Yes, y minus y1, then x2 minus divided by you are getting. Now in the same pattern, there are multiple number of points, n number of points are there. Then how to find the mathematical equation? Why? Because equation is must require to do any type of objective function analysis. Without mathematical equation, we cannot start my objective equation. What is the hypothesis first, right? I'll show you first how to prepare your mathematical equation from a given data set. One data set is given to you, find the mathematical equation first and check whether this mathematical equation is accurate or not. Okay? Then we'll go for the next round of analysis, right?
It's like it is not
Project.
Okay. Suppose that we added
I'll cover only the linear part. Non-linear part is very important to understand. So I'll cover the linear part. So linear part.
From those related topics.
So here like how many I try to give an example from power electronics, power system. Control system time is there. I demonstrate.
You want to go to the
small book. Bed in the slot. Sir, it's 25A or C? R.
Like August 2nd only the release.
Okay.
So only because of this FTP only I discussed. Okay, that's why so you used to work on the desktop. Now see, this is my window. All of you know this window. I will not extend it in window. I have some data sets with me. Three data sets I have. I'll just first explain what is the data set, and I'll show the details, right? How to work. I have. See, this data set is about only two parameters, one is reactive frequency, one is reactive power, one is the frequency, right? My objective is to create a mathematical equation which will satisfy this data set. That is my first. I'll start from there. I hope you know this one. Whenever you will get down, ask me. This is a data set. I have only two parameters. One is reactive power, one is frequency. And my objective is to create a mathematical equation which will satisfy this entire data set. Okay? There should not be any single glitch in the mathematical equation because based on the mathematical equation only, we are going to frame the objective function. Right? So my data is there in one folder called DAYANANDA. This is the folder name, right? So what I do, I go to my MATLAB window, right? And I navigate to that particular folder. I hope you know how to navigate to the folder. So my folder is on the desktop and this DAYANANDA. So data 1 now I am showing. So just open the data set whatever it is. And the data set you see here, two parameters is visible. One is reactive power and one is frequency and punch. These are two parameters, right? So just import, if one green color on this net, just import it. So you can import it, data imported to the MATLAB environment now. So now just close it. Because already workspace is filled, so you need to workspace. Once again, I will say one. Just import it. I can find the data set is available. File is data, right? Now I have two columns in the data set, right? I extract the two columns as individual. Segregate, I need to create an array. One array because it is not an array. So what I do, just same thing. File name is called data1. Data1, that's it. Bracket start, semicolon, comma, 1. First column, right? Bracket close, enter. Now my X array is created. This is array, not in the column number. Now I extract the second column, right? Same concept, just I will change that one to Y array. I have given the value of Y. But you need mind that my X is reactive power, Y is frequency, right? So both parameters both separated. Now what I need to do is just go to your apps. Something is there called cloud fitting. First you get cloud fitting. Right? Just open cloud fitting. Because no need to create mathematical equation by Excel sheet, it is very easy. This feature was not there in MATLAB 2015. After 15 onwards, we are getting this app. Before that, we used when we were student. It was there. Polynomials. Same thing I will go into 1 second. If you know, then I'll skip this one. I'll go to the ML part. So first parameter x is set from the workspace I am calling. Second parameter I am setting for y, right? Next to x it is asking which variable it is. So I am setting reactive power, right? Then frequency. If you remember, if the data set one is reactive or next to the data. How the data is there in the main data set, right? Data is like this. By default, if you see here at the right hand side bottom, it is showing some statistic information for the present data. Okay, this is the raw data. I have done same thing. Only one blue straight line is there. By taking that blue straight line as a hypothesis, that is what it's saying. Right? For that blue line, develop some mathematical equation. You can see that is that f of x is equal to p1x plus p2. Right? If you have done the constraint optimization, in all the constraint optimization problem, you have to give minimum boundary, maximum boundary. Just below that equation only it is showing what is the minimum value for minimum value for p1, maximum value for p1.
So sorry to interrupt you. You went to add some curve. So after that, what did you see?
Nothing.
Like, something you are adding.
No,
Okay.
nothing I have done. And it is showing for P2 variable what is the minimum 0.98, maximum 50.04. Okay. Intentionally, I have kept the frequency outside the boundary. Only to do. Now, based on this one, it is saying that your SSC value is now 0.03. Okay, it's showing error. Although error is very less because error means it has become 0. If it is 0 means it is high. Although it is showing 0 error, you see your R square value. R square. After it is saying that how your data is distributed across the hypothesis. I know how much 1. If it is closing for 1, your final equation correct. Or if it is wrong. Right? Now from these two parameters only, I concluded that my equation is wrong. It is wrong equation. Right? Now I have to change the format. Right? For changing the format, if you go to the top and take here all the different varieties available. All different varieties. Right? Best variety is the interpolate. Okay? No other method, just go for the interpolate. Just click on the interpolate and you see how this is. Sorry, smoothing. Okay. Now you see, I just click on the smoothing and you see the new mathematical equation. This is now new hypothesis. If you see the graph, you can find that now new blue line, it is almost touching all the dotted points in your boxes. Almost all. Right? Now smoothing. Depends because many parameters are there. You just check with which you are getting the final graph. Okay. This one I got this type of graph, right? With that one, now you see your R value how much it came? 0.76. Initially it was 0.01. Almost 70 is accuracy. Almost graph calculation. At the same time, you see SSC also touched 0.006. Initially it was 0.01. Now I touch up to 0.006. At the same time, root mean square error 0.01. Actually, in the ideal case, root mean square error has become 0. If it is 0 means now almost I can say that this mathematical equation is suitable. Okay, this mathematical equation is suitable for me. So with this one, now mathematical equation it is writing with p value also 1 it is by the second, but p value 1 hyperparameter. Already it is like the overhead. Okay, so overhead means what? Remember, variance is very high, very high. Okay, variance means your mean and deviation is getting center. Our objective is to coincide that one. Okay, if I go delta cutting out, you see how the delta looks like. I'll show you. just like this is the bell curve for that one. See here. See the bell curve. My objective is to make this bell curve as much as narrow as possible. Okay. Why it is running? Because it is getting one. It is overfitting. It is getting expanded. Right. So this is now play 100%. It will be inaccurate. It will not give you the correct result. After that point, size is also 0.1. But bell curve will be overfit. If you are getting like set, it is hard. That is also wrong because it is under. Okay, what do you mean by under? You surround this graph. This is how he is like good boy. Okay, I told him that. Sir, I'll give you one chocolate, but you don't tell it to anyone. Okay, that means what? He is low biased. Okay, even if someone offer him Cadbury Dairy Milk also, he will not take. That is low bias. That means underfitting curve. He is low bias, right? Suppose let us say today I have told Satashi sir, I will give you one chocolate. Tomorrow Madam said, I will give you Cadbury Dairy. Then he will orient to that side. Okay, that is called highly biased. Okay, right? If all your data points are coming on the curve, then it is highly biased. Okay, all data points should not come in the curve. If it is coming, it is saying that depending upon the data points, the equation may change. That means if I replace this existing data set with a new data set, then whatever algorithm I am developing, it will give highest error there. Suppose he is a student of, let us say, from this university, so teacher knows that in laboratory life, how it will happen. In laboratory, I give some extra marks, so I know it. If the same person with the same algorithm, if will come to my university where nobody knows him, same person may have some other marks in the same paper. Even if two evaluators also evaluating the same paper, will have a different opinion. Because it is human tendency. That means, so only it is basically examination, you should not evaluate with bias. If it not, then it is highly biased. So I should discard this type of curve. Clear? So different planes are there. You can just test with different planes and keep on noting down the RLC value, R square value every time. Right? So bell curve. Okay. Whenever you are writing any journal or any conference, you keep on adding all these things in regular format. Case number 1, with this type of spine analysis, I am getting this result. Case number 2, with that type of analysis, this is my result. And you are comparing that. These are hypotheses like that. So three hypotheses I am proposing. Let us hypothesis is the two ones based on the R square. Clear? Now it is objective of the paper should be like this. What hypothesis you are proposing, that must be scratched. Then only your check will be correct. That is how in mathematical writing, lemma proof. This is my hypothesis. This is the proof I am giving for that. Right? So if you have seen any electrical transaction paper also, they will write it. Lemma proof everywhere. Then only because they are claiming and they are rejecting that one. That is what hypothesis concept. I hope I may understand. So this is your AI, not ML. Analysis by this type of method is AI, right? I go to the ML part. Right? In any part, what will happen? Let us say I have another Excel sheet. Here, in this Excel sheet, you can find that R fetch, Y fetch, D fetch, real power, reactive power, frequency. I don't know because this is the raw data I am getting from the PL. This is the actual data from the PL or is the laboratory actual data. So here now you tell me what you want to predict. So say 1, 2, 3, 4, 5, 6 comes there. 1 to to predict. Suppose anything you predict that prediction means what? 6 columns there. 5 variable, 1 column as the output. That is what I am to do, right? 6 columns I will make 5 columns as the variable, 1 column I will make as the y, right? Now you need which one as y. Real power. So real power now you want as the y part. So just cut that one and then press it. Okay. So always keep the prediction at the end. Okay. So I have kept the prediction at the end now. Clear? Always keep. So starting from r phase, this is the first variable x1, second variable y phase, third variable b phase, x3 value, x4 value, x5 value. That means in the mathematical equation there will be 5 unknown quantity x1 to x5, and all this unknown quantity has to predict the final value, that is the real power. That means I will give input from x1 to x5 and I will have to take what will be the frequency at the next frame. Understood the case, like this is the start one by one, you see here. Now for simplicity what I do, I put here r and x1. Because very big names are there, so for my understanding. Then next to third variable x3, fourth variable x4, variable x5, final y. That's it. Done. Just set it over. Clear? Now see, I am going to develop an algorithm. Whether the algorithm is correct, how I will come to know what I need to do. This is not data set. No, that I do. But see, this is an algorithm. I was going to develop an algorithm. I will show you how the algorithm is developed. After that, I need to verify whether the algorithm is correct or not. Testing. I need to do testing, right? Testing means what? There are 2 types of testing. One is called black box testing, one is called white box testing, right? Black box testing means under testing scenario, you don't know what is the x values, right? But in white box testing, intensely you know this will be the value, right? So I show you both black box and testing, right? For black box testing, for white box testing, what I randomly I will take one row value, randomly, right? So you just tell me where I take. You tell me from which row I take the value. Any row. 100 row. So for 100 row, this is the parameter, right? Now just copy, create a new Excel file. Clear? For 100 row, I know the output will be 1.03. I know, right? Now what I do? I'll just copy the header file, like whatever value is. Done? I know my final value will be 1.03. Okay, just mention somewhere 1.30 will I delete that one. Not to delete it. Output testing. Okay. But I may get some error when I'm doing it. Yes. Test file creation over, right? Just close the test file and I will close the main file. So main file name is DAYANANDA, test is test. Right? What I do, I go to my main window. Everything is not clear. I simply call those 2 Excel sheets into my process. So one file name is DAYANANDA, second file name is test. That's it. Right? 2 files are there. Right? Result is important. Test 1 row. right? So into x5 and the y value input here. That's it. Right? So cross-segmented basically in our technical term, if you see journal paper or any why this one has window size. Windows same concept. Matrix only there was nothing else but big names. Nothing else. Over right. Let's start now. Then go to the maps. Start with but I don't know. And later I'll cut it. I'll show you. Classification. ML. Start a new session. That's it. Because all other parts are deactivated, only the new part section is active. Right? Now check your input variable, right? Now input variable is data2, not the test. It's only one row. Right? So the data, I am calling the data2, right? Now see here, already now x1 to x5. That means taking all these variables as your input, and it is saying that my output is the one that is the y. So it is not activated. But if you want to change, suppose your Excel set is like 500 plus 500 window size, then sometimes you need to change your come to object if there is x1 x5 y. That's it. Now okay. What was already all we have seen the neural network. And then some you have those layers, are there, right? This 5-fold is saying that is here and 5 different layers. Okay, if you keep on increasing the layer, accuracy will increase, but your time, it will take a lot of time to do, right? Sometimes even I have seen 3 days, 4 days also simulation is going on for one shot. So let us say let it be 5, but using a then another test, okay? Suppose you don't have that is what I told the black box, okay? Black box if you want to do, then you have to pick on the text, okay? Black box means now you are handing over the entire data set on the software randomly tests, okay? But here software will try to use it. So that is not at all recommended. Recommended is user is some input whether the algorithm is giving prediction or not. If software will do that one, then what is the use of my knowledge and things? So for that timing, I am not doing black box analysis, I am going for white box, right? White box means I uncheck the that's it. That's it. Nothing else. Just start this over. Now just sit and relax. Nothing to do. No coding. Nothing matter. Nothing. Okay. Just do some click. It will give all the output one by one. I'll show you. Now it is reading the data, the patterns, how it is. Okay. This is now your data. 5 data are scattered without 2 dimensions. If you want to be in 3 dimensions, right? This is now clear. Now you want to missing only algorithm, right? Take missing algorithm you name and start. Any any other principal components that point. Any other this is anything random. Okay, why I asked that one? Because if I go for SVM, that is linear regression, right? If I go for KNA or system that will be non-linear regression, that accuracy will be bit because in SVM sometimes what will happen, same thing what will happen now. R-square will be very less, but very fluent, but error. But accuracy is so now I do characterization, then one time should start all models machine learning model all they have base cutting. Okay, why we start set? You can see that on the left hand side is written trees there. Okay, if you open any MATLAB platform starting from 18 onwards, by default tree will give you. Okay, so depending upon your supply you want SBM. Okay, just see here. Because you can add base effect. That is the base probability, box plot, everything will come. So I go for a set SBM. You see here it is linear SBM. We are getting that's it. Now you can see here some parameter is inside. Why I can see here? Because sometimes what will happen if you are working on this system. Suppose I am working in this system, also panel in this system. Because machine learning is different systems capability. Okay, if I am recommending using machine learning, please go for I meaning. Okay, or else I will have to machine learning continuously. If I is this is new system I have okay, so go for like Jupyter notebooks or even for MATLAB also it is there, right? Go for it. Virtual work and Google 29 minutes. But I do the program for hours 84 hours to be touch base. Okay, because listening is not going on. So go for higher end systems, then you will be better. Very good, right? Don't touch all these things. Written there, train was selected. Okay, train is selected. Train was selected means now it will go for only SP. Okay, if I click on train all domains, it will take all the parameters into account and it will take a lot of time. Okay, one by one I will. Train was selected, it will start.